Hi, my name is Yusuf. I'm here to discuss about some topics in high performance computing. Uh, in modern computing, from our smartphones to world's fastest supercomputer, is, is the stored program architecture. The concept often called one architecture. It revolutionized computing by establishing one critical principle. Programming instructions and data are stored together in the same main memory. This managed by five key components. Main memory, which holds both data and instructions, and input-output devices, and central processing units, CPU. The CPU is where the magic happens, containing the arithmetic logic unit, ALU, for performing calculations, and control unit, which the, acts as the system manager, directing the continuous fetch, decode, execute cycle that brings any program to life. Now, to achieve high performance beyond a single CPU, we use cluster computing. Cluster computing is one of is not one large machine, but rather a team which which does which does the work in a group way. A team, a collection of interconnected independent computers called nodes that uh, works together as a function as a single and powerful system. It builds primarily to achieve increased speed and reliability. The cluster architecture relies on three main parts: the node themselves, the high-speed interconnection that allows to pass the data rapidly between them, and cluster malware. This malware is essential software that allows all separate nodes to look and behave like a single system image. Basically, middleware is helpful for making the whole cluster computing work together. It basically combines all the nodes, which are basically uh, single computing devices, single computing nodes, and their work and functions together to make a high performing unit. They provide excellent high availability and reliability. If one node fails, other can take over, often through process like detecting and masking faults. By combining the effects architecture of stored programming concept, we with the scaled power of clustering, we relay the groundwork for true high performance computing. This is the first topic which I have discussed here, and the second topic will be on its applications. The main clustering types of high performance clusters focus on speed and parallel processing, in which uh, the individual nodes will work parallelly, like taking the work and dividing the work between themselves and processing them in at a time, not one at a time. They will process all together, and after that, the result will be combined together. That's how the high performance cluster will work. And it also focuses on reliability and uptime, often uses primary and backup nodes. And it also balances, it also does the load balancing cluster, which distributes the network traffic across all the nodes and multiple servers to prevent overload. If if we didn't use a load balancing cluster, then if the workload on a node is increased, then it will be overloaded and which may lose the functionality of the node and the high performance will be reduced. The performance rate will be reduced. Uh, so, huh, and we have also discussed about our second topic, the cluster computing, which does that, which basically combines all other nodes together. Like for transition to cluster computing, it introduces a particular application of high performance needs contrasting in it as a team of powerful computing components rather than a single super machine. Define a uh, when we define a super computer cluster as a group of interconnected independent computers that works together as a simple computing resource to achieve increased speed and reliability. In cluster malware, the software that makes the system look like a single system image SSI to the user. Finally, emphasize the core benefits offered by cluster, which are cost efficiency by using of the shelf components, providing high scalability. Uh, by simply adding more nodes, we can ensure that high availability and uh, reliability by detecting and masking faults, making them ideally for complex problem solving like scientific simulations. As we know, for scientific simulations, it's much complex than the normal simulation. Normal simulation works on uh, simulation works on simple simple clusters which are very easy to run and they doesn't have much complex issues in it. So when we use it, use this single system image for a scientific simulator, it will be more useful since it will make a since it will use more number of nodes that can do this scientific simulation work much faster than normal simulations. So can basically say that the component will work more efficiently, more fast than normal simulations. Thank you.